some of this may ring some bells from when you've done study skills in the past, but some of it, I hope at least, will be new to you. I want to teach you a little bit of how memory works. As I said, this will be something that hopefully you've heard bits of. And then I want to draw out, in particular, two really important implications, sort of ramifications of the way that our brains are and therefore how we need to think about them. Okay? So here's the lesson. Okay? When we think about memory, memory is a single idea. It's actually got three different parts, and we've done a lot of cognitive science into this, right? I'm not sure if anyone knows what the three parts are called. Two are famous, one not so much. The first kind of memory is the one that you're all experiencing right now. When you sense things around you, when you see and when you hear and smell and all that, this is loaded into your brain this second, and it's kind of like has no limit to it, right? You can take in, it's one of those things about why, if anyone's gone to the Grand Canyon before, which I have not, but you go there and it's kind of like, whoa, this is amazing. You can take it all in. And then when you look at photographs of it later on, you're like, yeah, it's not as impressive because your brain can actually handle more than a picture can, right? So sensory memory is really amazing because it's unlimited for this short amount of time, but of course it has a big problem, right? What's the big problem with this sensory memory? It's immediate. It just kind of vanishes, right? We forget most, like, I'm just going to pull a number out of the air because I'm probably larger than this, but 99% of all the things you see, hear, smell, touch, everything, they just go. Now, quick question to you. Why is this the case? Why is our brain designed to do this? Because some people don't do this and it's actually a huge problem for them. Max? It's not useful. Can someone drill in on that? Like, why isn't it useful? I'd love to remember everything that I ever saw. Why might it be actually not useful?
Because you've got all these other moments in the rest of your day that you need to get more bits of sensory information. If you could retain everything, you'd overload.
Yeah, that overload idea is really important. I don't know what your desk at home looks like, but can you imagine what your desk would be like if it could never forget anything? If you could never clear it away and say, here, I want to do something useful, right? If it just amassed forever, it wouldn't be useful to us anymore, okay? Now, like I said, this is the memory that not many people sort of think about because it's just kind of there. The memory that more people associate with, sorry, this is a bit funny, is the stuff that you actually have retained for a long time, like years and years and years, okay? Now, just like sensory memory, this is unlimited, right? You can remember some really unimportant things from a long time ago. You're like, why do I still have this in my brain? But it will just stick around indefinitely. Now here's the trick. These are not the only two memories that matter. In fact, these are not the two memories that matter the most, I'd say. There's one in the middle, and it has a special name. I hope you know it. What's it called? Yes, that's right. So we can call it either short-term memory or a more descriptive name is actually working memory. Have you heard this phrase before? Working memory, okay? Now, if you haven't heard it before, that's okay. It's exactly what it says. It's memory you have to work on to hold in your brain. And importantly, unlike your sensory memory and your long-term memory, it's limited in capacity. It's enormously limited, okay? We generally say you can have 7 plus or minus 2 items. If you're really exceptional, you can hold on to 9. If you're a bit of a dory, maybe 5 or 1 or none, right? Now, this is really important. How do these all fit together, right? Well, we know that this stuff just gets forgotten unless you pay attention to it, yeah? If you think, you can hold it in your working memory. But then how do we get this stuff over into long-term memory? That's actually what we mean by learning, right? What do you actually do to get it over there? What do you think you will? Repetition, you think, right? You go over and over and over again. So essentially, we call this rehearsal, right? Not everything in working memory gets retained. A lot of it is forgotten as well. But it'll stick if you go over and again and again and again. Rehearsing is of many different kinds. The two that really matter for us in terms of how you learn stuff and get stuff to stick in, right, is that you can either encode, which is to put stuff into your brain and importantly, think about it, like put attention to it, not just write it out verbatim, right? You actually perhaps think carefully about how it's structured and then put it in a picture or a mind map or something like that. And then when you grab it, right, it's why we ask you guys to do practice papers, actually. It's like when you retrieve that knowledge there, it sort of enforces, hey, this matters, this is really important, keep on thinking about it, right? Okay, now this is the basic lesson I wanted to give you, but the implications are the part that matters. Like, otherwise this is just facts in your brain, okay? So let me draw out 2 really big implications that I hope are going to change the next hour and 15 minutes of your life and then beyond, okay? How do we actually remember significant amounts of things to work on them? You know, that 7-item limit is like a big deal. That's a small number, right? Now, the main way is what psychologists call chunking, which is to take like separate items and like group them together into single chunks, right? And then you can say, this is not a bunch of things anymore, it's one thing that I can hold it in my memory. Now I'm going to illustrate this for you. In a second, I'm going to flash up 12 numbers. 12 numbers. That's more than your working memory is supposed to hold. But I'm going to ask you to try and remember them nonetheless. I'm going to give you, they say working memory is like 5 to 20 seconds. I'm going to give you 8 seconds to look at these numbers and try and commit them to memory. Are you ready? So I'm just priming you so you're paying attention. Here come the 12 numbers. Eight seconds goes fast, doesn't it? Boy, and you're like, I didn't even remember what was the start here. But some of you are working really hard. Some of you are working really hard and you still got them in your memory. Okay? Now here's what I want to do. I want to show to you the importance of and the value of chunking, right? How you can take something like that which you're still furiously trying to hold on to, and despite the challenges, actually remember it. Now, just a quick thing, I want to make sure you guys have a realistic situation. So normally, you don't just get to spend all of your attention remembering something. You have to remember even without that constant attention. This is something that a guy named Hermann Ebbinghaus, German psychologist, really memorably shown in this forgetting curve, right? Now have a look at this. If I wanted to make you forget those numbers, all I could have to do is wait. If I just wait, the number will go, right? But it's worse than that. Research shows that if you get given conflicting information that's similar, right, a whole bunch of other 12-digit numbers, it becomes increasingly difficult to grab on to that memory. And the most important thing, working memory, right, takes work, takes effort. I can completely destroy all of your working memory by giving you something that sufficiently is interesting to grab your attention. And I don't know if you've seen this before, but for me, like I can never not laugh at this. Like it's just, and I just watch it over and over again, and I feel bad for him, but it's still objectively funny. Okay. Now I'm going to put money on the table that pretty much everyone in the room has forgotten the original 12 numbers that I showed you. Okay. Maybe you're like, I'm still holding on. Okay. Now I won't test you. It's just an exercise. You yourself know whether you can remember them or not. Here are the 12. Now I want to show you how chunking works to take something like this, which sounds like it should be very difficult, especially with all the distractions I've been giving you, and actually remember it. Look closely at these numbers. These numbers are actually not 12 numbers. They're actually 1. And maybe if I rearrange them, you'll see how. These are the same 12 numbers. I've just reversed them. I wonder if you noticed that they're deliberately chosen, right? In fact, the exact sequence of numbers you've got is the time that this lesson began, right? Now, when you think of this as one object, the time this lesson started, it's actually not that hard to remember. It's how I remembered it when I was typing up this slide. Once it's one thing and not 12, suddenly you're, oh, this is not so challenging, right? You've got it in chunks. Okay, so there's the first implication. And we do this all the time, by the way. Think of something as complicated as, can you tell me what this is? It's tying your shoelaces specifically, right? Generally, this is the particular knot people use on their shoes, right? Now, I think we've all forgotten because of our age how really challenging it was to learn this the first time. And looking at it like that, you're like, whoa, this is so complicated, okay? Now, let me try and bring it back to us, right? When you look at this, you've known this formula for a good couple of years now. Do you think of this as 16 objects? That's what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? Or do you think of it as 1? When you become familiar with it, it becomes the quadratic formula, right? Okay, so that was the first implication. I want to do one more, and it's actually the one that's sort of been bugging me. It's kind of the principal reason why I wanted to do this now rather than any time. I want you to think really closely about this. See, when you pay close attention to something and you think hard about it, that's how you actually retain things in memory. It's why when you like multitask, if you like have a video on while you're like, if your phone or the TV's on while you're doing your homework, it sort of mucks up this process, right? Because what you're encoding is not just the thing you're thinking about, it's what's around you. When you're having a conversation with someone whilst you're doing work, you're also encoding that. You don't have a choice about this. It's the way that your brain works. Now, right at the start, and it was quick, I admit, I showed you this picture. And I wonder if some of you wondered what it was. Now, in fairness, I didn't show you the whole thing, which is where the lesson really is. This is the whole picture, okay? Now, the particular feature I want to draw your attention, you might be able to guess now that I'm showing you the whole thing, it's this brown, dirty patch here. Does anyone know what this thing is called? It has a name. It's actually a phrase, a dirt patch. Pretty close. Actually, it alliterates with dirt patch. This is what we call a desire path. A desire path. I don't know if anyone's heard this phrase before.
Dirty patch to me, mate.
Designers talk about these.
I see it all over the path.
You see them all over, right? Some designer went and put in paths in this park. Right? They're like, I want people to walk here and walk here. What did people do? They're just like, I can get there faster, right? I'm not going to walk all the way here. It's Pythagoras, right? I'm not going to walk all the way here and then turn a junction, right? I can get there faster, okay? Now, this is the way your brain works. Memory is formed the way this desire path is formed. There's this psychologist, I think he's in the UK. His name is Daniel. This is the way he puts it. You want to remember something? You want to retain things in memory. Memory is the residue of thought. It doesn't matter how much I tell you things if you do not think consciously about them. If you do not guard your attention as you're working on something, when you think about that task in front of you, you won't remember it. Does this make sense?